Now let's say we had a problem. Like the absolute value of x is greater than 3. And so if we draw a number line, and we say this is 0, and here's 1, 2, 3, 4, 5, and we go the opposite way. Based on what we know, what this problem is saying is that what are the solutions of x that has a greater distance than 0 to 3. If this is 0 to 3 right here, it's saying, well, what are the values of x that's a greater, in this way we think of a greater length than 0 to 3. And so any point here and any point here to the right is going to be greater than that length, right? So these are all solutions. So if we plugged in 4 for x, it would be absolute value of 4, which equals 4, and we know that 4 is greater than 3. But there's another solution to this problem, because we go the opposite way. So if there's a distance of 0 to 3, like that, and we ask you what the absolute value is, well then, if we drew another distance from 0 to infinity, we would see that any point here and past to the left will have a greater length from that point from 0 to 3. So all the solutions from this point onwards is also a solution. So if we took, let's say, -5, right, that falls here, it would say, and we plug that in for x, we'd have the absolute value -5 equals 5, and we know that 5 is greater than 3. So that's pretty much the solution. Any number to the left of -3 and any number to the right of 3. Now the question is -3 and 3 solutions to the problem? So if we plugged in a -3 here, we would have -3 absolute value equals 3, but 3 is not greater than 3. So that's not a solution. All right, so 3.1 is greater than 3, 3.2 is greater than 3, but 3 in and of itself is not greater than 3. And so the way we would answer it is that, or we draw it out, is that we draw an open circle here, saying that 3 itself is an answer, but 3.1, just like a minuscule amount, it's greater than 3, is an answer. And same thing here. If you plug in 3 over here, and you get the absolute value of 3, which equals 3, and you can't say that 3 is greater than 3, because it equals 3. And so this also would be an open circle, and everything to the right of this would be. If the question was, is the absolute value of x greater or equal to 3, then when we plug in 3 for here, and we say, well, that equals 3, and is that greater than or equal to 3? Because there's that option of like, is it greater or equal? Then we can say, yes, 3 is a solution to this problem. And then the way we classify that answer is that we fill that open circle in. So to recap, if it was x greater than 3, the answer would look like this. 1, 2, 3. And it'd be an open circle here, and you fill in everything to the right of it. And then you go -1, -2, -3. You have an open circle here, and you fill in everything to the left of it. Right? And that's what it would look like on a number line. But if you had x is greater than or equal to 3, and you draw it out on the number line, you'd say 0, 1, 2, 3, and then you have a closed circle, and you fill in everything to the right of it. And you say -1, -2, -3, you have a closed circle, and you say everything to the left of it is an answer choice. Now if you add is less than 3, and now it's the same thing but opposite. So you have -3, -2, -1, 0, 1, 2, 3. And I'd say, well, here's the distance from 0 to 3. So what are all the solutions that's less than this length? And so you'd say, well, here's 3. So any distance that's this length, any solution on this point of the of the line would be less than this length that's 0 to 3. So you fill that in by having an open circle here and filling everything in there. But in the same way, the distance from here to here is also 3. So the numbers less than this length, this distance, is also a solution. So put an open circle here. And all these answers are an answer as well. All these values are an answer to the solution. And if the question was, what is the absolute value of x is less than or equal to 3, then you would fill in those points, and that would be the answer.